afternoon, everyone. In this tutorial video, we are going to learn about the introduction to organic chemistry. Organic chemistry in the past was regarded to be the aspect of chemistry that deals with compounds that can be seen in human body or in a living system. So therefore, they call it vital force. The aspect of chemistry that deals with vital force. This vital force is believed to be in every living system. Now, as science progresses, knowledge also evolves. So we get to an aspect whereby a scientist, known as Werner. Werner is actually the name of a scientist that nullifies the definition of organic chemistry as as the aspect of chemistry that deals with the vital force. With this experiment, ammonium cyanide. Ammonium cyanide is an inorganic compound. So we believed before that organic chemistry always deals with every compound that can be gotten from a living system. But ammonium cyanide can never be gotten from a living system. It is an inorganic compound. So after Werner treated ammonium cyanide in the presence of great heat, and the result was the production of an organic compound, which we know as urea. Urea is actually contained in our urine, which is gotten from from living system. This is urea. Urea is organic, while ammonium cyanide is inorganic. So we have successfully produced an organic compound from an inorganic compound. This was the reaction that Werner produced, and we nullified the definition of organic chemistry as the aspect that deals with vital force. We said, okay, since we can never get ammonium cyanide in a living system, and we got a product that can be gotten from a living system from an inorganic compound. So we nullify this definition as the aspect that deals with vital force. We now define organic chemistry as as the aspect of chemistry that deals with compounds that contains carbon. Carbon containing compounds. Carbon containing compounds. And in this aspect, we also have exceptions. There are some compounds that will contain carbon, and in essence, they are not organic. For instance, we have carbon dioxide, carbon monoxide, and all carbonates. All carbonates, they all contain carbon. They contain carbon. But all of them are inorganic. All of these are inorganic. So these are exceptions. These are exceptions of compounds that will contain carbon and will never be organic. Example of an organic compound actually is This is a methane, for instance. This is a methane. It contains what? It contains carbon and 4 hydrogens. So this is the definition that is what? That is generally acceptable for what? For organic chemistry. Now what is the importance of organic chemistry? Importance of organic chemistry. Majority of our products that we use today are gotten from what? From organic compounds. For instance, methane. For instance, methane is a gas. Methane is a gas. It's a natural gas that can actually be used to what? To generate fuels. You can use it to generate fuels. Our petroleum actually contains carbon. The food we eat, ranging from carbohydrates, lipids, proteins, all of these are what? Are organic. They are organic. Why? Because they contain what? They contain carbon. Carbohydrates, for instance, now. Carbohydrate, for instance, is a what? It's a polysaccharide that is gotten from simple connecting units, which are always come monosaccharide of what? Sugar. Which is what? Which is actually glucose. And if you check the chemical formula for glucose, carbon is always contained. This is glucose. There are 6 molecules of carbon in what? In a glucose. So also fructose, 6 carbon containing compound. A lot of glucose will actually give us a carbohydrate. Lipids as well, which are lipid and fat and oils. Fat and oils are actually gotten from fatty acids. Fatty acids. And fatty acids are what? Are organic. Our proteins, each proteins that we have is actually gotten from what? From amino acids. From amino acids. So, when amino acids form bonds together with the nitrogen side and the other side, then we have what? We have proteins. Now we have seen the importance of organic chemistry because the food we eat, all of them are organic. The clothes we wear are organic. The house we live are made up of organic compounds. Organic chemistry is very, very important. This actually takes us to another aspect that we'll talk about right now. We said organic chemistry deals with what? With the aspect that contains what? Compound that contains what? Carbon, with the exception of what? Of the carbonates, the oxides, and the sulfides. The sulfide, this is also inorganic. It is an exception. Now, since there is a special treatment, special preference that is given to what? To carbon. So, a normal person will ask that why carbon? Why carbon? Why is carbon so important? Why is it important? Why is a whole aspect of chemistry that we call organic chemistry is being dedicated to what? To carbon. Why? Why is carbon the only compound in what? In the periodic table. Now the first answer to this because carbon is what? Is at the center. Carbon is at the center of the periodic table. In the periodic table, carbon is always at the center. Now let's quickly take a look at this. Let's quickly look at this. I'm going to use the first 20 elements to illustrate the point that carbon is actually at the center of what? Of the periodic table. This is actually the first 20 elements in the periodic table. These are the first 20 elements. When you take a cursory look at this, you will see that we have how many groups? We have 8 groups. There are 8 groups in the periodic table, and carbon, which is here, falls to which group? Group 4. Of course, what is the half of 8? Is it not 4? So carbon falls at what? At the center of the periodic table. That is the first reason. Carbon is the first element that falls at the center of the what? Of the periodic table. And carbon, that is the first reason why carbon is very, very important. It's very, very important. Another point is that carbon is what? Is tetravalent. Carbon is what? Is tetravalent. Tetravalent is actually gotten from the fact that carbon has 4 valency. Carbon has 4 valency. Anywhere you see carbon in a compound, carbon usually forms 4 bonds. For example, in methane that we add the other time, carbon is actually bonded covalently to 4 hydrogens. The tetravalency of carbon, which we will further explain when we get to hybridization and electronic configuration of carbon. Carbon will always have 4 bonds under normal circumstance. Under what? Normal circumstance. Carbon will be bonded to what? To 4 different groups. To 4 groups of atoms. That is the tetravalency of what? Of carbon. It is not every element in the periodic table that has this special ability that carbon has. Some atoms in the periodic table, under normal circumstance, will have just only 2 bonds. Example is what? Oxygen. Under normal circumstance, oxygen will have what? 2 bonds. It is like this, bonded to 2 different groups or the same group, or like this. Although oxygen has what? 2 lone pairs of what? Of electrons, which we will actually talk about when we get to what? Lewis theory. And also, there are some atoms in the periodic table, for example, nitrogen. Nitrogen, for example, we have what? 3 bonds surrounding it. Under normal circumstance. Under normal circumstance. Nitrogen, we have what? 3 bonds surrounding it. Or in some other cases, you can have this. You can have this. Nitrogen can actually be like this. And also, nitrogen can assume this position. Nitrogen can assume this position. It all depends on the what? On the type of compound where nitrogen is actually from. So what we are saying in essence is that carbon is very important because why? It will, under normal circumstance, has 4 bonds. How many bonds? 4 bonds surrounding it. It is not all elements in the periodic table that has this special ability. Tetravalence. Carbon is able to assume tetravalency. Why? Because it is sitting at the center of the periodic table. Another reason why carbon is very, very important in chemistry, insofar that a whole particular aspect of what? Of chemistry is being dedicated to the what? To the study of carbon, which we know today as what? Organic chemistry. Is because carbon has the ability to what? To catenation. Catenation is actually the ability of an atom to what? To form bonds. To form bonds with itself. A long, continuous straight chain, or even it can be branch. This special ability of carbon makes it to be very, very important, make it a force to be reckoned with when we are dealing with chemistry. Insofar that a whole aspect of chemistry is being dedicated to what? To carbon. For instance, carbon has this special ability to form a strong continuous chain with itself and with other elements in the periodic table. This is what we call catenation. It is not all elements in the periodic table that has this special ability of carbon. Carbon is so very much important. For instance, the carbohydrate that we consume every day, proteins that we consume every day, they all involve catenation. Because carbohydrates contains hundreds of carbon. Hundreds of what? Carbon. So these are the special ability of carbon to form a chain that will be up to 100, even thousands. This special ability of carbon to catenate, form bond with itself and to the other atoms in the periodic table makes carbon to be what? To be a force to be reckoned with. Carbon is very, very important. It's very, very important. Now this will take us to another point that we call what? Classes of organic compounds. Classes of organic compounds. We have already seen the importance of organic compounds. Now, we said these organic compounds are numerous, ranging from the food we eat, the carbohydrate, the lipid, the fat and oils, the proteins, the clothes we wear, the house we live, the rubber we use, and a host of others. Now we have classes of organic compounds. We have classes of organic compounds. Number one we will look at is the what? The saturated organic compounds. We have some organic compounds that are saturated. When we say a compound is saturated in chemistry, it actually means that what? It has actually used up its what? Its bonds. It is like a bucket of water that has already been filled with water. It won't be able to what? To take more water. Except if you want to pour the water away. So when a compound is saturated, an organic compound being saturated, it means that what? It has used up its valency. Example of this, of the saturated organic compounds, are the what? Are the alkanes. Alkanes. For example, ethane. Ethane, for example. This is ethane. When you look at this, carbon has used up its valency, all the four bonds. It has used it to bond with 6 hydrogens. Now, another classes of organic compound that we have are the what? Are the unsaturated organic compounds. Unsaturated organic compounds actually are two. Unsaturation means they have not used up their bonds. They can actually take in some bonds, like a